Hey, welcome back. We'll continue right on where we left off in the previous lecture, and I want to talk about the string copy again. Just in case the documentation is not clear, I'll demonstrate this string copy. What we have is this safe string copy. It's going to copy the name into the full name. Okay, so if I build a run, that is what we get. We get Bruce printed out. I can also decide how many characters of name I want to copy into full name, and I can do that. Just copy and paste that by using strncpy. Now I would like to mention that you have the unsafe version and then the safe version as well. And with this we have to specify the in. We pass that in as an argument, and that is going to be how many characters we want to copy from the C string name into the C string full name. And that is going to be the final argument that we pass in. So we're going to copy the first 3 characters. Of course, if you try and build a run, we'll get that error again. And then we have the string, the safe one, which is going to be strncpy_s. Build and run, and we get BRU printed out. So it's going to copy only the first 3 characters from name over to full name. Down here we print it out again, alright. By doing this twice here, so I'll remove the second copying. I just wanted to show you that we can specify how many characters we want to copy. Next, as a recap, notice the difference between copying and concatenating. So we are copying and then we are concatenating. But let's say we change this final one here to copy. You may have noticed this already because we did copy twice before. But if I build a run now, we get just the surname Lee here. And that's because that copy is going to override what we had before, which was this copy right here, the concatenate, and then we do a copy again. So I'll just undo that. As with string copy, we can specify how many characters we want to concatenate from the source C string to the destination C string. So let me go and change this final one here, for example. This is going to be strnccat_s for the safe one. Then we have to specify the size again, the number of characters. You can see we have size_count for the final argument. So I'll do comma. And let's say we do only one, so we do Bruce space and L. Let's see if that works. Build and run. That's what we get. We get Bruce. We append a space and then we append the L by simply doing this concatenation here. And we specify, okay, we only want to concatenate that one argument from surname into full name. Of course, you can change that as well. I'll do 3 here, and that should now append all 3 of those. I'd also like to mention with the older one, the string copy, so the non-safe version, I'll just go and uncomment this here. So I define that CRT for C runtime secure no warnings. Then I can actually do this right here, right within the console statement, because of what the string copy is going to return. As I mentioned, it's basically going to return a pointer to that destination. If I build a run, we get Bruce printed out, which is the destination, and that is going to be the full name. We copy Bruce into full name and then we return the C string full name, basically through a character pointer, and of course the overloaded stream insertion operator will be able to read that. But notice that the save version, if I do _s, build and run, we will not get the results that we would expect. We get 0 printed out. And that is because it's going to return something different. It's not going to return a pointer to a char. The safe versions of the string concatenate and the string copy functions, for example, will return 0 if successful. So in other words, we don't get an exception, or they will return an error code on failure. Whereas the older non-safe versions of those functions, string copy and string concatenate, will return the destination string as I've demonstrated. So these are things that I wanted to demonstrate. There's a bit of a difference between what we may see in the documentation with the non-safe versions and what we'll get with the safe versions of these functions. Okay, so at the end of the previous lecture, in the first part of this discussion here, I tasked you with an exercise to go and find the length of a string, such as the name C string here. So I'm purposely keeping all of these C strings so I can demonstrate, and I'll go and change this. Of course, if you looked at the documentation, you would have found this string length function, and I'm just going to pass in the name. The string length function is going to return the length or the number of characters within that C string, up to and not including the first null character. So you may want to pause the video for a second and think about, if you pass in name and surname, and also full name, what do you expect that to return? Alright, so let's build a run here with the name. We get 5. Even though name is C-string with 6 elements because it has the null character, we will only get 5 because it is not going to count the null. If we try with surname, we'll get 3. And with full name, of course, we are going to get 0 because it has only null characters in that. And let's go and be silly here. I'll do Bruce, the null character, and GG, and maybe a space, just a bunch of random characters here, but notice we have the null terminating character as well. So if I put a name in there and I build a run now, once again we will get 5, because the algorithm is going to read this a null character, and so it's only going to count the first 5. You can also do something like that, add a space. Now we should get 6, and that's what we get. But of course, if I remove the null character, build a run, we get 9 now. Okay, so just messing around here, you get the idea. Let's look at an example. The string length function is going to return the length of the given string, up to and not including the first null character. So if we consider the name C-string, which stores Bruce currently, and if we consider that the sentinel is going to be the null character, that is going to indicate the end of the C-string, then we can do something like this. Now, of course, this is just a high-level example. We are not really concerned with the actual implementation, but we can do some while loop while the character sentinel is not equal to the null character. Then we want to increment the count. The count is going to be set to 0, of course. So we're going to increment up to and not including the null character. When we reach the null character, iteration is going to stop on that array. B is not null, so we increment count. Count is now 1. R is not null, so we increment count again. Count is now 2. U is not null, so we increment count again, so count is now 3. The character C is not null, so we increment count again. Count is now 4. E again is not the null character, so we increment count once more, and so count is now 5. The sixth element, so with index at 5, the character E is going to be null, so that is going to fail. We do not increment count, the loop is going to exit, and we will return that count, which is referred to as the length of the given string. But there's one more thing. If you think about the size of operator, and I pass in a name, that is going to return the amount of bytes represented with that C-string. If you remember, it chars 1 byte. So if I build around the string length is going to return 5, but the size of is going to return 6 because it's going to include the null character. So using the size of operator is one way that you can get the length of the C-string, including the null terminating character. So I hope you got that one in the exercise. You can test the other one, such as full name, for example. The size of operator should give us 20, and the string length should give us 0. Build a run, and that's what we get. The string length is going to be 0 because it has a bunch of nulls in there. And then we get 20 with the size of, and of course we specify the size of that full name array, character array, to be 20 characters. Okay, a couple more notes for you. Where we do the string concatenate, for example, let's do this one right here, string cat underscore s. We have to make sure that the destination C-string is modifiable, or in other words, not const. If it's const, then of course you cannot go and modify the elements. So if I build a run, we will get an error because those arguments are not going to match, and that's because this is going to be const, and of course we want that to be modifiable. So we have to keep this in mind. We have to ensure that the destination C-string is not const, and so that it is modifiable. I'll actually do string copy, and of course the same thing is going to apply to that. And what we can see, if we look at the prototype again, the source is a pointer to a char constant. So what does that mean? Well, it means that we can pass in a C-string such as name here. I'll keep these for a bit later. So we can pass the C-string in for an argument. If I build a run, we get Bruce printed out. But we can also pass in a literal because that is a const parameter. Build a run. point with that is we can pass in a literal, because the formal parameter for the source is a pointer to a char constant. Now with that, I'd also like to note that let's say we go and do surname here. Let's say that is a pointer to a char. We cannot initialize it, and this way again we are going to get an error here. A pointer to char const cannot be used to initialize an entity of type pointer to char, but we can do it if it is a pointer to a char constant. Always remember that the order here does not matter. It really depends on how you want to read it. So it's a pointer to a constant character, it's a pointer to a character constant, or however you want to read that. You can do it in this way as well, that'll work. And now we can actually pass that in. So I'm passing in the surname, and I can build a run, and you can see that works fine. And that's because the string insertion operator, if I do Ctrl-K, Ctrl-I, that is overloaded to take in the output stream and a pointer to a char constant. Also, don't get confused, don't try and dereference that, because you have to remember your pointer arithmetic and also the relationship between arrays and pointers. If you try and dereference this, this is basically the same as doing this. If I build around that, we will get L. If I do 1, we will get E, and so on. Okay, if you remember that. And again, the stream insertion operator is overloaded to work with this pointer here, so we don't have to go and be concerned with dereferencing or anything like that. Similarly, if we have a pointer, I'll just go and remove const. Don't really need that for this. I'll do a pointer to char, call that surname, and then I'll allocate a new array on the heap, and I'll initialize this to Lee, so I'll pass in. So I'll use the C string initialization to initialize that. You can use individual characters as well if you want to initialize in that way. And then down here, I'll make sure to delete the array pointed at by the surname pointer. And still, if we build a run, you can see that that prints out, that works fine. Okay, with this console output. Now with your understanding of object-oriented programming, you can start to think, okay, we can create some string class, which can solve some of the issues that we have with the older C strings, because we have to keep track of and make sure that we have the correct size and so on. Whereas if you use dynamic strings, dynamic C strings that is, if we go beyond the size that is allocated, then of course we can just allocate a new array on the heap and then copy over the characters and so on. But we don't have to implement that ourselves. We actually have a string class in C++, which we'll discuss in upcoming lectures. So that is done for us already. And with the dynamically allocated arrays, we can still go and use them. So copy surname into this string copy function. So we copy surname into full name, and then we print out full name. Build a run. You can see that works. We get Lee, print it out. If we want to determine the size of the surname using string length and the size of operator, then the string length should give us the length of the string, which is currently going to be 3 for the surname, but the size of should give us the size of a pointer. If I build and run, that is what we get. And it's the same thing if we go and do it in this way. So we have a pointer to a character constant again, and we go and print that out. That is now pointing to some constant that we initialize that to. Instead of a variable, we go and copy surname into full name again, print that out, and then we go and print out the size of the surname. If I build and run, again we get the Lee printed out. 3 is the length of that string, and then 8 is the size of the pointer. Alright, so these were just a couple of things that I wanted to demonstrate that you have to keep in mind. With this example, I wanted to show you that we can use a smart pointer instead of doing new and then having to do delete. That is, when we want to allocate a C string on the heap, we can use a smart pointer instead. So I have some source C string. We are going to copy that into the C string, which is managed by the unique pointer here in a second. Here I go and do auto. This is the name of the unique pointer. I'll call that UP for unique pointer underscore C underscore string. Then I have the make unique. I pass in this right here. We want to have this unique pointer manage an array. Then I can calculate the size for that. How many elements is that array going to have? We can pass in the string length, the source C string, plus 1, because remember the string length is not going to calculate or return the size of the string plus the null. So we have to add 1 for the null terminating character. As mentioned, you can use the size of operator since those stars account for the terminating null character. Then I can go and use the string copy. Notice I'm using the older one. I'm going to define the C secure no warnings up here. And I'm going to copy from the source C string into the unique pointer C string, and I use .get to get the pointer. Then I can do console output unique pointer C string, and then I can also do a modification. So I can do unique pointer C string, use the subscript operator, pass in an index. So in this case, we want to modify the first element to M. So we go from Bob to Mob, and then I print that out again. Okay, so I'm gonna build and run, and you can see we get Bob printed out first, then we do the modification and we get Mob. So with this, we can have a dynamically allocated C string that is managed by the pointer. We don't have to manage it ourselves. And in this example, it's also not const, so we can actually modify the elements. Now again, we are using the older string copy here. If I change this to _s, you will notice that we get an error here. That is because this takes in as a formal parameter reference to some array. We are not passing in an array, we are currently passing in a pointer. But if I press the down arrow, we have one more overload here, which takes in the as a formal parameter pointer to a char for the destination, then a size in bytes, and then a pointer to a char constant for the source. So let's go and pass in the size in bytes. I'll just pass in 4. We need to make sure that the size accounts for the terminating null character following the string Bob here. We can also calculate that. I'm just currently passing that in with that literal, but it might be best to actually calculate that. But in any case, just for demonstration, I'll go and build a run here, and you can see that works. So just wanted to demonstrate the different ways of how we can allocate, whether it's on the heap or on the stack, a C string, and that those work with the console output, and we can also use the functions such as string copy and so on with those C strings, and how we can do that. Okay, I'll do some cleanup, and we've seen the string length function, and I've also discussed some of the functions that we can do on characters. So what we can do is, let's say we have some for loop and we want to iterate over that C string, and we want to make sure that every character is an uppercase. Then what we can do is, now we want to use functions such as the toUpper function. So what I'll go and do is, I'll go and include the cctype file. Now I'll get this error here, expression must be modifiable L value. So I'll go ahead and remove that const. So again, what we are doing is we are fetching that right here, cstring I, passing in the index, and we use the toUpper function to make sure that that character is the uppercase of that character that we have passed in, and then we assign that back again at that particular index. Then we go and print that string out again. Now we get Bob printed out in uppercase. Now what we can also do is we can make a check, so we can make sure that we want to check if the character is an alphabetical character. So if the particular character is an alphabetical character at that particular index, then we go and do this operation. We ensure that the particular character is converted to an uppercase. If it is not uppercase already, and then we go and print that string out again. Alright, so this was just an example of how we can combine operations on characters and operations on C strings. Okay, one more example of these functions that operate on C strings. I have two C strings here, cstring1, cstring2. Both of those are currently initialized to Bob. Just do that semicolon again, and that will format my line for me. Then I have this console output. I do this string compare, strcmp for string compare. So I'm going to compare these two strings. Yes, and that is going to return something here. Basically what it's going to return is, it is going to return 0 if those two strings are the same. It's going to return a negative value, so -1 for example. If a character in the left-hand argument is going to appear before the character in the right-hand argument, that is in lexicographical order. And then of course it's going to return a positive value in the other way around. So if the character in the left-hand argument is going to appear after the character in the right-hand argument, again in lexicographical order. Currently we can see both character string 1 and 2 is the same. So I'm going to print this out here. Those two are equal. Otherwise I'm going to print out those two are not equal. In this debug string we get 0 because those two strings are the same currently. Bob and Bob are equal. But if I change this one to A or B, then you can think for a second we should get a negative value, because string which I pass in here in the left-hand argument, A is going to be before B. So I'll just build and run that. And you can see we get a -1, and those are not equal either. And also if I change this now to something like A, the B character comes after the A character lexicographically, so this should now give us a positive value. If I build and run, you can see we get 1, and those are not equal. And basically why I'm showing you that is you can do certain checks, and based on those results you can do other things. But for now we are mainly concerned with if these things are equal or not. If this calculation is the same as 0, then we know that those two strings are the same. I'll just comment these out. And I'd also like to note that you can compare a certain number of characters within those strings. So we can go and specify that here. Control + spacebar, we can see the max count. Let's say we compare the first two characters. I'll make sure both of those are Bob again. And if I build and run, we get Bob and Bob are equal. But the problem here is that if I go and change, let's say the second one to BOS instead of Bob, and I build and run, then we get Bob and Boss are equal, which is not the case. But in some cases you may want to check only for the first couple of characters, alright? If that is the case, then you can use this version of the function strn compare. Okay, so with that we are going to wrap up this lecture. I'd like to mention that you also have a bunch of other functions such as strchr, which is going to find the first occurrence of the character, and these have relatively simple examples. You also have another one which is going to find the last occurrence of a character, also with a simple example. That is on cppreference.com, which I mentioned earlier on in the lecture. My goal again is not to cover all of these functions, so I'd just like to mention that there are a couple of other ones that you can check out. We may or may not use some of these functions going forward. Okay, so we've talked about C-strings. Now of course we can have a class that manages a C-string for us. And we already have that in C++ with the string class. So we will discuss that in an upcoming lecture.